Okay, welcome back YouTube. We're here with another specified prac. You must be loving these by now. We are looking at the efficiency of a water heater. Just get to it straight away. You are going to need a power source set to 12 volts. I'm not sure if you can see, Mr. Han, but I've set the twiddly end to 12 volts. I've got a beaker of water. I've measured 50 centimeters cubed. Doesn't matter necessarily how much water you have, just as long as you note it down. And then I've got what we call an immersion heater. So the first thing I'm going to do is just make sure that that immersion heater is in there nice and safely. And finally, I've got my thermometer. So what we're looking at today is the efficiency of this water heater. Efficiency is all about the balance between input energy and our useful energy on the other side. So our useful energy with a heater is heat, thermal energy. So the first thing I need to do is at time equals 0, I'm going to measure the temperature of my water. That's my starting temperature. So I've got 28. I'm then going to turn on my power supply and at the same time start my stopwatch. Now, every 60 seconds for 10 minutes, I am going to record the temperature. So, if we're heating the water, we're expecting that heat to go up. So, independent variable in this case, time. Dependent variable, the temperature of the water. Control variable, I've got the same mass of water the whole time. I'm keeping it in the same beaker. I'm using the same power supply and the same 25 watt immersion heater. So Mr. Lahan will do the time lapse now. We'll come back with some results and analysis at the end. So we've done this practical now. 10 minutes well spent in my eyes. We're going to talk about some inaccuracies first. First, massive inaccuracy. My water in this beaker got pretty hot, okay, but I will have lost some heat to the surroundings. And I think this has been shown towards the end, okay, where it went 34, 34, 35, 35, 35. So we didn't heat up much at all. My second inaccuracy is that every time I wanted to measure the temperature, I'd pull the thermometer out. Obviously, the thermometer is going to cool at the point where I pull it out. So, first improvement, insulate it. Maybe a wine jacket, maybe some blankets, just anything to stop that heat getting out. And then use a digital thermometer. We're now going to talk about the analysis we need to do. So the first thing we need to do, if we're talking about efficiency, is calculate the total input energy. And we can do that using our equation here, energy transferred equals power times time. My power of my lovely immersion heater was 25 watts and my time was 600. I transferred 25 times 600, which is going to give me 15,000. So that's my energy input, my electrical energy into the heater. I'm then going to do the energy gained by my water. So this is the useful energy, and I do that using an equation. Energy gained by water equals temperature rise times 4.2 times my mass of water. So my energy gained. My water went up by 7 degrees. If you look, it started at 28 and it finished at 35. I'm going to times it by 4.2, and because it's 50 millilitres, I've got 50 grams. So my answer for my total energy, which was transferred, is 1,470 joules. Last thing I want to do then is work out my efficiency. Efficiency equals useful output energy divided by your input energy times 100%. Well, we know that my useful energy was 1470. My input energy was 15,000, which means that the efficiency of our water heater was 1,400 divided by 15,000 times 100. Remember, hit that Scooby-Doo button if you need to. And I've got 9.8%, which is pretty rubbish, really, isn't it, Mr. Han?
Yeah.
It's not the best heater in the world. But hope you've enjoyed it. Like and subscribe.